Hello everyone, this is the video for section 6.2. In the coming chapter we're going to be learning about this weekend, right after the midterm. I want to go over some key ideas just about slope in general in a graph before we start answering the questions that are in this section. So there are really four kinds of situations when we talk about slope. We have a positive slope, we have negative slope, we have no slope, and then we have a fourth situation which is slope is undefined. The approach you want to take with this is when you're reading a book, we read it left to right, and that's how we work with things here. So this is going to be section 6.2, and we're just going to introduce things this way. So when I read this graph left to right, you'll observe that the pattern of this is that as I read left to right, the line is going to the right, it's going up. And because as we go left to right, the line is going up, we say that that line has a positive slope. On this one here, if we go to the second graph to the right, we observe here that as we go left to right, that the graph is going down. And we say that that line has a negative slope. We'll come back to those two in just a moment to talk about how we begin to quantify those slopes. In these last two graphs here, these are kind of special situations. So we looked at a line with a positive slope, we looked at a line with a negative slope. For this third line here, we'll notice as we go left to right, the line is not increasing, the line is not decreasing. So we characterize that line as not the slope of it not being positive or negative, but just right in between positive and negative, which is 0. And then for this last graph here, we don't encounter a line at all, we don't encounter a line at all. And then all of a sudden, as we're reading this left, we encounter the line at once, and then don't encounter the line at all again. So we're going to characterize the slope as being undefined. So we're going to take a look at how we begin to quantify these slopes and how we characterize the slope of this. So slopes are going to vary differently, and we'll see how we figure these out going left to right. So there's going to be something I use, which is called a slope box. And it kind of works like this. And this is how we kind of find the slope. So what we're going to do is we're going to write the slope as a fraction. We're going to talk about how we change going from one point to the next. And we're going to put that change in y on the top. So we're going to give that a triangle. That triangle stands for delta in Greek, which represents change. So that's going to be, move that over a little bit here, it's going to be the change in y divided by the change in x. So when we talk about the change in x, we're going to read this just going left to right. So as we go left to right. So x is always going to increase as we go left to right. However, in the case of the direction of the line, sometimes we may go up as we go left to right, which would indicate a positive slope. On other instances, as we go left to right, sometimes the line is going to go down, which means that this is going to give us a negative value for y, or a negative change overall. By the way, this should be the change of x here too. So we have the change in y divided by the change in x. So we're going to see how we find the slope of these two lines in these instances here. So we have here, I'll take a couple points here. As I'll take this point, this is going to be 1, 4. And we want to go from this point to the next point. So for this point, we go to the right one, but we go up 1, 2, 3. So if we go to the right one, I'm going to block this off here. We go to the right one, we go up by 3. We would say that the slope of this line, which we're now going to introduce with a variable m. So when you're looking at the slope of a line, we're going to use m to characterize what is the slope. We're going to say that the slope is going to be equal to 3 over 1, or just 3. What you notice here is that every time I go to the right one, I'm going to go up 3. Go to the right one, go up 3. Go to the right one, go up 3. And any straight line in our Cartesian coordinate system will keep holding that same pattern, because if it didn't, then the line would not be straight. It would have to either slant in a different direction or be curved to meet the next set of points. So here's our slope box here. We went to the right one, we went up 3. That gives us a slope of positive 3. Because remember, when you go up, that's going to be positive. Let's go ahead and make a slope box to see if we can capture the situation going on in this graph here. Okay, I'm going to draw my arrow to the right. That's always going to be positive. And I either want to go up or go down. So let's just say I choose this point here, and I'm going to go over 1 now. So if I go over to the right 1, that's going to be a positive change of 1. However, I'm going to decrease by 2. I'm going to decrease by 2. So my slope is going to be negative 2 over 1, or in this case, negative 2. So I would say that in this graph, the slope of this line is equal to negative 2. You can write that as negative 2 over 1, but wouldn't make any difference. The slope is still negative 2. So let's go to this next part here of 2 more graphs. I want to make sure that these are shown. Let's see how the slope box works with these to characterize the slope of these lines. So in this one here, I'll just put a couple points on the graph here. And watch how this changes. So I'm going to put my slope box over here for this. By the way, a slope box is my concoction. I came up with this. So if you're looking for it elsewhere, don't bother. No one else has it, just me, unless someone's copied off me over the years. Okay, everyone can see that? So remember, I'm going to capture the change of x here. So I'm going to go over 1, 2, 3, 4, 5, 6, 7, 8. So I go to the right 8. But notice here I'm not going up, I'm not going down. So I'm going to write that as 0 divided by 8. So in this case, the slope is equal to 0 divided by 8. And if you perform the calculation on that, 0 divided by 8 is just 0. Let's take a look at the last problem to see how this plays out. So let me just put a couple points here. And as I go left to right, and I'll put my slope box over here now. As I go left to right, there's no change left to right. So we're going to capture that with a 0 here. But however, from this point to this point, we go up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we're going up positive 10. So that's going to be positive 10 here, but a 0 here. And as everyone knows, if you take 10, set that equal to m, and I divide that by 0, 10 divided by 0, do it on your calculator, you're going to find that that slope is undefined. So we use a slope box to capture these changes, and we're going to use slope later to do some graphing as well, as long as we know what the slope of a line is. So that is my video on slope. We're going to go ahead and go into some questions now. May not get to everything in this section, but we'll certainly get to some of these. So I'm going to move through some of these quick, as I'll be providing some instruction in class. It says, determine if the given equation is a linear equation in 2 variables. So any equation that's going to be a linear equation in 2 variables is going to be like y equals, it can look something like mx plus b, where it has just a y by itself or an x by itself. It can be y equals some number, and it can be x equals some number. These are all examples of what that could look like. Some non-examples, so these are examples. Some non-examples are ones that are going to have either an x squared plus da-da-da, y squared plus da-da-da, or something with an x times y. So if you see anything with an x squared, a y squared, or an x times y, these are not examples of linear equations in 2 variables. Now here I do know that it says 2 variables, but sometimes we're in the graph of a straight line, we only need to use 1 variable, and we'll talk about that when we encounter that. So looking at question 1, this is pretty close to this form here, except we have an x and this is a y, but that is an equation, a linear equation in 2 variables. Here we have this x, we have this y. Now there's some numbers by this, that's fine. That's an example here. Taking a look at example 3, we see we have an x squared in that. That's going to make it a quadratic equation. So that's going to be a no. And then for number 4, it says y equals minus 5. Well, we talked a little earlier about we can have y equals some number, and that's going to certainly work. So yes, that's going to be an equation. It's going to be a linear equation. And we'll take a look a little later how the graph, what the graph of that looks like. So in this next problem here, we're going to go ahead and we're going to take a look at how we first determine these points. that we're going to use to complete the table, which we did in the last section. And then we will go ahead and plot those points. And if you do your math correctly, everything should plot on a straight line. So what I'm going to do is kind of work through these. I'm not going to show all the work like I did in the first chapter. I'm just going to get the points down and make sure we can plot them. So if we have y is equal to 0, that's going to be x plus 0 is equal to 6. Therefore, x will equal 6. Here we have x equals 4. That means 4 minus y equals 6. So let's go ahead and do that one. So we have 4 minus y equals 6. If I subtract 4, that's going to be negative y is equal to 2. Or if I divide by negative 1, y will equal negative 2. So I'm going to put negative 2 in place of y here. Here I have y is equal to negative 1. So for the other one, I'm going to say now, making sure everyone can see this still, that x minus a negative 1 is equal to 6. If I simplify this a little bit, that's going to give me x plus 1 is equal to 6. And then if I subtract 1, x is equal to 5. So what I'm going to do now is I'm going to take these points, 6, 0, 4, negative 2, 5, 1, and I'm going to try plotting these, and I want to make sure that they land on a straight line. So the point 6, 0, that's going to go 6, 0. Okay. We'll go and label that point A, but we won't put it here yet. We have point B, 4, negative 2. Now, you may not have to do this part of your homework where you have to give it a variable. I choose to do this for labeling purposes to kind of show you what's going on. So there's a point 4, negative 2, and then here's the point 5, negative 1. So here's 5, negative 1. And it appears that these 3 points, A, B, and C, appear to land on a straight line. So your graphing tool on the computer will go ahead and put a straight line through these, or you may need to do some of that work yourself. But it appears that these land on a straight line, and we've now come up with 3 different plots and plot a line through the points generated from the table in the equation. Okay, let's go ahead and take a look at number 6. So we're given the equation y equals negative 4x. So I'm going to plug these values in for x and find my y. So negative 4 times 0 is 0, so y will equal 0. Negative 4 times negative 2. Negative 4 times negative 2 will be positive 8. So I'm going to put that here. Negative 4 times 2. That's going to give us negative 8 here. So all I'm doing is I'm taking these x values and putting them into here. You can do this at home. I'm just working through these quickly because I've already showed this. So I want to make sure just everyone is familiar and comfortable with completing these tables, then plotting the points down. So we have the point 0, 0 here. We have the point negative 2, 8, so that's going to be negative 2, positive 8. And then we've got the point positive 2, negative 8. So we're going to positive 2 and negative 8. Now it seems like a pretty long line, but it sure looks like I'm going to be able to draw a line straight through these 3 points. Sometimes, if it doesn't appear correct, like if you have 3 points that don't map on there, you first want to check to make sure whatever points you have here, you've plotted them correctly. Once you've ensured that you've plotted them correctly, then you want to make sure that your calculations over here are correct. Okay, let's go on to the next problem here. So if you don't like working with fractions, you let your calculator do the number crunching then. So 1/4 of 0, I'm going to put that in. That's going to be 0. 1/4 of negative 8, negative 8 times a fourth, that's going to be negative 2. And 1/4 of 8 is going to be positive 2. So now I've got those 3 ordered pairs in the table that I'm going to go ahead and plot. One is 0, 0. One is negative 8, negative 2. And the other one's going to be 8, positive 2. And sure enough, it looks like these are going to form a straight line again. And you use your tool on the calculator to draw those, but we're just kind of teaching how this works here today on paper. Let's go ahead and take a look at the next one now. We have y equals 2x plus 2. We're going to graph this. So I'm going to show you how we graph this now. So first off, if we look at an equation like this equation is written in the form of y equals the slope times x plus b. So what I'm going to do is I'm going to take what's in this, which is y equals 2x plus 2, and I'd take each part out. So a few things to remember. So when we're looking at this, The b value is going to tell you where you begin to plot these points. And where you begin is always going to be on the y-axis. The m part is going to tell you how to move. But remember, what's this? This is the slope. Okay, so let's just take these one by one here. So for this one, from the equation here, we can see that b is going to equal a positive 2. And by saying that we're going to begin at positive 2 is we're going to go ahead to positive 2 on the y-axis. So we're going to go to positive 2 here on the y-axis and start plotting a point there. From here, we're going to use the slope. Now, it gives us a slope of 2, but I can write that as 2 over 1, which means that I'm going to go to the right one, and then I'm going to go up 2 to plot my next point. Now, the graph paper on this particular problem, at least the one I printed, is pretty small. So I'm going to go to the right one, up 2. I'm going to go to the right one, up 2. I'm going to go to the right one, up 2. I'm going to go to the right one, up 2. Now, you don't have to do this too many times. But you see, if you keep repeating that, you're going to get a bunch of little points that should generate a straight line. If you keep going to the right one, up 2. And then you can use a line to not only graph the line that goes through those points, but then find other points that you get out of the graph. So that is example 8. Let's see if we can find one more of these to show you before I go to another one. So here's the next problem. We have x plus 3y equals 9. To do this one, what we need to do is we're going to rewrite so it looks like y equals mx plus b. Now, this is not the only way to do this, but this is something that you should be comfortable with doing, which means we want to get the y by itself. So when in the last chapter when we were getting variables by itself, this is an application of where this is going to be very useful. So if I'm given my original equation, x plus 3y equals 9. What I'm going to do first is I'm going to go ahead and subtract x on both sides. Or if you want to, you just move it to the opposite side like I've taught you before. And that's going to give me 3y equals negative x plus 9. From here, I can divide everything, like each part, by 3. And if I do that, that's going to be y equals negative 1 over 3 x plus 3. Now I have this written in y equals the slope times x plus the y-intercept. From this, I can see the y-intercept is going to be 3. So I'm going to go on the y-axis to where it is 3 and put a point there. The slope, let me put down that b equals 3. The slope is negative 1 over 3. So what that means is, from the point I've plotted where I begin, I'm going to go to the right 3, but now I'm going to go down 1 each time. So then to go to the right 3, down 1. To the right 3, down 1. To the right 3, down 1. And you see, if you keep following that, you should in fact get a straight line. I'll do the best I can to draw that on here. Here we go. And I now have the graph of this equation for question 11. Let's see if we can find one more example of this. Yes, here's another nice example for question 12. And I'll start going to what the vertical and horizontal lines look like. I think question 13 on there is a review question. I'll let you worry about that. Here I have y equals negative 1/2 x plus 1. So in this one, b is equal to 1, and then m is equal to negative 1 over 2. So in this graph, I'm going to start at b, which is at 1 right here. Actually, no, it's scaled a little differently. So I'm going to put it here, and then I'm going to go to the right 2, but because this is negative, I'm going to go down 1. So then go to the right 2, be careful, down 1, go to the right 2, down 1, and so on. Hold on, this point right here, okay? Put that there. And I know graphing this is a little hard. I'm going to try to turn it on an angle so I can see the points more clearly. There we go. There we go, that's a better line. So now I have successfully graphed that equation using the slope and y-intercept method, which you'll see me go over in class. There's two more lines I'm going to show you quickly. First is going to be number 9. And that's going to be this here. So we want to graph the line of what this is, x equals -6. So all I'm going to do is, this is a graph that's going to cross the x-axis. Where is it crossing? -6. It's going to be across the x-axis at -6, so I'm going to put this here. For anything x equals something, I'm going to draw a vertical line. And you'll notice here that on all these coordinates, this is like -6, 0. This is -6, 1, -6, 2. All the x-coordinates are -6. So lines with x are always going to be vertical lines. On the flip side, the last equation we're going to do in this section is going to be question 10. And this is going to be the graph of y equals -4. So this is going to be a line that crosses the y-axis at -4. So it crosses the y-axis at -4. So for this one, we're going to go ahead and we're going to draw a horizontal line. A little crooked, my apologies. I don't have a ruler handy for this. So this is a horizontal line crossing the y-axis at -4. Anything where it's y just equal a number, where there's no x, if you're talking a 0 slope, these are always horizontal lines. And that concludes my lesson for 6.2.